Hello learners, welcome to the course Statistical Methods for Economics, Validity and Reliability. In this session, we will discuss the concepts related to explaining what is meant by validity, describing the nature of content validity, criterion validity and construct validity, discuss the nature and importance of phase validity, understand the concept of reliability, discuss the different types of reliability, comparison between validity and reliability. In the previous module, we have discussed about the concepts how a questionnaire can be constructed with an example of a case study of impact of reality shows on public. In detail, the construction of the questionnaire has been explained, and after the collection of the data, we have discussed the format of data entry into the MS Excel, which would ease the procedure of maintaining the huge volume data and carry out the statistical analysis of the data. Once the data is collected, it is important to check for validity and reliability of the data. In this module, let us discuss about the concept of validity and reliability, the various types of validity and reliability measures, also about the differences or comparison between validity and reliability. Validity. Statistical validity can be defined as the extent to which drawn conclusion of a research study can be considered accurate and reliable from a statistical test. To achieve statistical validity, it is essential for researchers to have sufficient data and also choose the right statistical approach to analyze that data. The validity of a measurement tool is the degree to which the tool measures what it claims to measure. Validity is based on the strength of a collection of different types of evidence. In general, validity can be defined as the ability of an instrument to measure what it is intended to measure. However, different people have defined validity in their own way. Some definitions are degree to which the researcher has measured what he has set out to measure. This definition was given by Smith in 1991. Are we measuring what we think we are measuring? This was suggested by Kurlinger in 1973. Extent to which an empirical measure adequately reflects the real meaning of the concept under consideration is as defined by Babi in 1989. The main purpose of validating a tool is to check whether the research investigation provides the answers to the research question for which it was undertaken. If it is providing the answers, are these answers obtained using appropriate methods and procedures? We shall now look into the steps involved in validating the tool. Developing a draft tool which encompasses criteria to be used in evaluation of the study objective. Pilot testing of the tool. Revising the tool according to pilot tests. Validating the tool with certain statistical measures. We shall now look into the different types of validity in detail. Internal validity. Internal validity is the extent to which we can be confident that a cause and effect relationship established in a study cannot be explained by other factors. That is, in other words, can we reasonably draw conclusions from the sample to the population of interest? Basically, there are four types of internal validity. They are construct validity, content validity, phase validity and criterion validity. The internal validity is very important in the researcher's perspective as it makes the researcher's finding credible. This is done when an experiment shows a causal connection between two data. Overall, internal validity is important to prove the trustworthiness of your research findings. The following could be the threats to internal validity. Single group threat. Single group threats to internal validity refers to threats that can arise when your study treatment focuses on one group. Multiple group threats. Multiple group threats to internal validity refers to threats and criticism that can arise when your study is focused on multiple groups. Social threats. Social threats to internal validity imply threats that occur because of the reaction of people to what affects them and others. It is important to identify the threats to internal validity in a research, as this will help the researchers to develop a control measure for study. External validity. External validity is the validity of applying the conclusions of a scientific study outside the context of that study, or it is the extent to which the result of a study can be generalized to and across other situations, people and times. There are two types of external validity. They are population validity and ecological validity. The following could be the threats to the external validity. Sampling bias. The sample is not a representative of the population. History. An unrelated event influences the outcomes. Observer bias. The characteristics or behaviors of the experimenters unintentionally influence the outcomes, leading to bias and other demand characteristics. Have-thrown effect. The tendency of participants to change their behaviors simply because they know they are being studied. Testing effect. The administration of pre-test to post-test affects the outcomes. Aptitude treatment. Interactions between characteristics of the group and individual variables together influence the dependent variable. The threats for external validity could be encountered through replications. Counter almost all threats by enhancing generalization to other settings, populations and conditions. Field experiments. Counter testing and situation effects by using natural contexts. Probability sampling. Counters selection bias by making sure everyone in a population has an equal chance of being selected for a study. Population validity. Population validity refers to whether you can reasonably generalize the findings from your sample to a larger group of people. Population validity depends on the choice of population and on the context to which the study sample mirrors that population. Non-probability sampling methods are often used for convenience. With this type of sampling, the generalizability of results is limited to population that share similar characteristics with the sample. Ecological validity. Ecological validity is a type of external validity that asks how well a study reflects everyday, real life or the user's real work context. It is about how accurately the study can be generalized to other situations or settings, or how informative the study is for policy, society, culture, etc. Construct validity. The degree of agreement of a device with its theoretical concept is known as construct validity. If you develop a questionnaire to diagnose depression, You need to know, does the questionnaire really measure the construct of depression, or is it actually measuring the respondent's mood, self-esteem, or some other construct? To achieve construct validity, you have to ensure that your indicators and measurements are carefully developed based on relevant existing knowledge. The questionnaire must include only relevant questions that measures known indicators of depression. The statistical tool used for construct validity is factor analysis. Content validity. Content validity measures the construct of interest. For example, if a researcher aims is to determine knowledge and attitude towards COVID-19, then the measure should include items or questions about both knowledge and one's positive attitude. Content validation is usually not evaluated quantitatively. It is evaluated cautiously, examining the measurement method against the conceptual description of the construct. Criterion validity. Criterion validity is a method which gives nearly the same information as a criterion with recognized validity. Whenever a new questionnaire or scoring system is developed, criterion validity is performed by comparing the performance with a standard. Face validity. Face validity refers to how well a measurement method appears to evaluate the construct of interest on the surface. The similarity between what is intended and what is actually accomplished is known as face validity. Face validity is a very weak indicator as a measurement method. One reason is that it is based on people's assumption about human behavior. Example, if a mother reports that the child consumes 2900 calories per day, but the child is severely undernourished, then the assessment is not face valid. Reliability. According to Anastasi 1982, reliability refers to the consistency of scores obtained by the same individuals when re-examined with the same test on different occasions or with different sets of equivalent times or under other variable examining conditions. The term reliability is also called consistency, reproducibility, precision, as well as repeatability. One cannot expect test results to be perfectly consistent as there are numerous other factors. If a single test is administered to the same group at two different times, some variation in score is observed due to temporary fluctuations in memory attention, effort, fatigue, and similar other factors with a longer time period between tests. Now, we shall discuss about the different methods of determining reliability. Test-retest method. The stability of a measurement procedure is assessed using test-retest method on separate days. On day 1, a test is performed which is then repeated on day 2 or later. The correlation coefficient between the two sets of score is used to compare the scores from these two tests. Both tests employ the same version of the measuring processes. For each test, the samples should be the same or similar. That is, the sample features should be closely matched. The measuring process is regarded trustworthy if there is a high correlation between the scores of two sets. This is done by plotting scatter plot or by calculating Pearson's R, that is correlation coefficient. Generally, correlation value for test-retest should be plus 0.80 or greater. then it indicates good reliability. The test-retest reliability can be improved by carefully considering the following points. When designing tests or questionnaires, try to formulate questions, statements and tasks in a way that won't be influenced by the mood or concentration of participants. When planning your methods of data collection, try to minimize the influence of external factors and make sure all samples are tested under the same conditions. Remember that changes or recall bias can be expected to occur in the participants over time and take these into account. Parallel form reliability. Parallel form reliability measures the correlation between two equivalent versions of a test. You use it when you have two different sets of questions designed to measure the same thing. This parallel form of reliability is important if we want to use multiple different versions of a test. You first need to make sure that all the sets of questions or measurements give reliable results. In educational assessment, it is often necessary to create different versions of tests to ensure that students don't have access to the questions in advance. Parallel form reliability means that if the same student takes two different versions of a reading comprehension test, they should get similar results in both tests. The most common way to measure the reliability through parallel form method is to produce a large set of questions to evaluate the same thing, then divide these randomly into two question sets. The same group of respondent answers both sets and you calculate the correlation between the result. High correlation between two indicates high reliability. Split half method. Internal consistency is evaluated by splitting the items into two sets, that is, dividing them on the basis of odd and even number of items or into two halves, first half and second half. For each set of items, the scores are computed. The correlation between the two sets of scores are examined using scatter plot or by calculating Pearson's correlation coefficient. Correlation value of plus 0.80 indicates greater internal consistency. Cronbach alpha. Cronbach alpha is the most commonly used measure of internal consistency or reliability. It was developed by Lee Cronbach in 1951. It determines the reliability of multiple question Likert scale surveys. That is, it measures how the test items are closely related to each other. The formula for Cronbach alpha is alpha is equal to n into C bar divided by nu bar plus n minus 1 into C bar, where n is the number of items, C bar is the average covariance between item pairs, nu bar is the average variance. The interpretation of Cronbach alpha is as follows. If alpha is greater than or equal to 0.9, then the reliability of the tool is excellent. If alpha is between 0.8 to 0.9, then the reliability of the tool is good. If alpha is between 0.7 to 0.8, then the reliability of the tool is acceptable. If alpha is between 0.6 to 0.7, then the reliability of the tool is questionable. If alpha is between 0.5 to 0.6, then the tool has a poor reliability. The tool is not acceptable if the alpha value is less than 0.5. Now, let us look into the differences between validity and reliability. If it is asked, what does it tell you? It could be that the validity tells us about the extent to which the results really measure what they are supposed to measure, whereas reliability tells us about the extent to which the results can be reproduced when the research is repeated under the same conditions. Suppose if we are interested to know how they are assessed. The validity is assessed by checking how well the results correspond to established theories and other measures of the same concept, whereas reliability is assessed by checking the consistency of results across time, across different observers and across parts of the test itself. Then, if we are asking about how do they relate to main study, then it could be that a validity measurement is generally reliable if a test produces accurate results. They should be reproducible, however, a reliable measurement is not always valid. The results might be reproducible, but they are not necessarily correct. It is very important that for any of the tool, the reliability or validity is not met, then it is suggested to construct a new tool rather than revising the tool. Summarization. In this module, we have discussed the concept of validity and reliability of the tool, the various purpose of validating a tool, and the steps involved in tool validation is discussed. Also, we had a detailed discussion about the types of validity such as internal validity, external validity, construct validity, content validity, phase validity, criteria validity, etc. Then we discussed about the concept of reliability, the various methods of determining the reliability of the tool like test-retest method, parallel form method, split half method, Cronbach alpha method. Finally, we understood the differences between concept of validity and reliability. Thank you.